In section 6-6, we're covering the fundamental theorem of algebra. You have learned several important properties about real roots of polynomial equations. The following statements are equivalent. A real number r is a root of the polynomial equation p of x equals 0. P of r equals 0. R is an x-intercept of the graph of p of x. X minus r is a factor of p of x. When you divide the rule for p of x by x minus r, the remainder is 0. R is a 0 of p of x. You can use this information to write a polynomial function when given in zeros. Notice that the degree of the function is the same as the number of zeros. This is true for all polynomial functions. However, all of the zeros are not necessarily real zeros. Polynomial functions, like quadratic functions, may have complex zeros that are not real numbers. The fundamental theorem of algebra states every polynomial function of degree n is greater than or equal to 1 has at least one zero where a zero may be a complex number. The corollary is every polynomial function of degree n greater than or equal to 1 has exactly n zeros, including multiplicities. Using this theorem, you can write any polynomial function in factor form. To find all roots of a polynomial equation, you can use a combination of the rational root theorem, the irrational root theorem, and methods for finding complex roots, such as the quadratic formula. The complex conjugate root theorem states if a plus bi is a root of a polynomial equation with real number coefficients, then a minus bi is also a root. Number 1 on classwork 6-6 says a polynomial has the zeros shown along with other possible zeros. What is the minimum degree of the polynomial? And find an additional zero of the polynomial. Since we have 6, 1, and 4 plus 7i, we know that another zero must be at 4 minus 7i. This means the minimum degree would be 1, 2, 3, 4. So there would be at least 4. Number 2 says a polynomial has the zeros shown along with other possible zeros. What is the minimum degree of the polynomial? And find two additional zeros of the polynomial. Because we have these two complex zeros, we know other zeros would be the complex conjugate, so 2 minus 6i and 1 minus 7i, giving us a total minimum degree of 1, 2, 3, 4, 5, 6.